about us understanding how snow fall and like snow loads are changing here in Utah, and how he uses R to do that kind of analysis. So that will be happening next month. We're probably going to take December off, and then we'll probably come back in January with a new with another starting off the new year. So that's a little bit about what is happening there. As you all come in, so if you are a local Salt Lake person, we do in-person meetups roughly once a quarter, where we have networking time together. So we'll set some of that, probably not until the new year. We'll set up another time to do some local networking with people who are here. But as many of you all have found us, we do these talks fully remote on Zoom, roughly once a month here. This is a friendly and professional space, and we use the R Consortium Code of Conduct here. And so Andrew and I are the moderators, and so we are the ones who are responsible for how we treat each other. And so just as if we were in person with each other, and we would treat each other with professionalism, we have that same set of standards here. So I just dropped the link there to the R Consortium's Code of Conduct. And yeah, I think that is about it. That is about it of announcements and those kinds of things we're getting going. I'm really excited about today's session. So today's session, our speaker is Nick Tierney. And Nick Tierney is someone who's worked as a research software engineer, worked a lot on R packages, has worked on packages for missing data, for data visualization, and currently is someone who works as a consultant doing all kinds of things for R and data science. So if you need Nick's skills, which are amazing, I think this will be a good way to get introduced to Nick. So Nick, I'm really excited about the talk you prepared for us today, which is about how to write good functions. So Nick, welcome. We're so happy to have you here with the Salt Lake City R user group. Thanks so much for preparing this talk and getting to share it with us.
Awesome. Thank you so much, Julia. And thanks for the lovely introduction. And it's so nice to see, my R friends here. Hey, Emily, and, there's like see JD Ryan and Amelia and a few other friendly folks there. It's nice to see you. I'm looking forward to seeing you in person at a conference at some point soon. So today I'm going to talk about practical functions, practically magic. This is a talk I've given a couple of times before, and each time I kind of iterate on these ideas a bit. It's sort of, I think, similar to like one of the key messages in this is that writing functions is like writing text. It takes iteration, like things get better. And every time I go through this, I think, like there's just a few more things I want to make better. And so, I think we're always learning and always like getting things, um, like we're always just working a little bit closer towards communicating exactly what we want to say. So one day I'll write something a bit more formally, but yeah, I'm really excited about this. I think that writing good functions is really something that fundamentally like improved how I write and how I think about problem solving. And yeah, so as Julia said, I'm Nick Tierney, but I am now a freelance stats consultant, and I'm calling from Nipalina Lutruwita, which is Hobart, Tasmania. That's the um, Palawa language for this place. Um, so, the talk today is aimed at a broad range of people. So I think that you'll get something out of it if you've never written a function. You'll get something out of this if you've written a couple of functions. And you'll also get something out of this if you're a skeptic function user or if you're a regular function user. I'm going to talk about why I care about functions and some of the fundamentals with functions, and and then I'll show some things in practice as well. Can you see my screen okay? I've just got like the Zoom thing up here.
Yeah,
Is
this
that
looks
blocking the
great.
title? Cool,
No,
great.
no, we can see your
Cool.
screen really well.
Excellent. So today's talk is borrowing from many different other talks. I've drawn a lot of inspiration throughout my career from Hadley Wickham. He gave a talk called Managing Many Models at the Wombat Conference in 2016, held in the Melbourne Zoo. It was a very memorable location, and that was like a really mind-blowing talk for me. He introduced the map functions from Per and showed them in like really cool examples. And so I'm drawing a lot of inspiration from his talk there, and The Design of Everyday Functions, as well as Code, Smells, and Feels from Jenny Bryan at USAR in 2018. It's one of my favorite ever talks, as well as Roger Peng's keynote at USAR 2018. Miles McBain's talk, Our Color of Magic. And there was a really awesome data science hangout from Joe Cheng from, I think, a year or two ago. And yeah, so I guess I just want to say, like, these aren't necessarily new ideas, and I'm drawing a lot of inspiration from some of these leaders. And yeah, so let's talk about this plot. This is, I believe, figure one from my first ever paper. And this is the missing values in a data set of people's health data. And on the bottom, we have the variables and the rows. The rows, so these are the columns and the variables, and the black shades there. So the gray shades in this plot mean missing values. This is the precursor to what would later become the VisDat package. And my motivation for missing data kind of stemmed from this problem here. There's a lot of missing data. So there was about 67% missing values, which is like more than half. It's a problem. It's a lot. And so today I wanted to talk about writing functions initially in this context of kind of a gnarly problem with missing data. So let's look at the ozone data set here. So the impact of missingness, so we're going to look at, say, just two variables here, temperature and solar radiation. And so we see here we're looking at the values of temperature and solar radiation, and sometimes solar radiation is missing, and we want to explore how those temperature values are different when they are missing versus not missing. So to show this visually, this is the vismiss package, so the vismiss function from the visdat package. So what we're looking at here, the missingness of, say, solar radiation. There's a few of these values that are missing, and then we're also looking at the value of temperature here, which is all present. So we're looking at like how these values of temperature are different when solar radiation is missing versus not. Or to show this again a different way, on the x-axis we have temperature, and then on the y-axis we've broken this into two pieces for when solar radiation is present versus when solar radiation is missing. So we get a sense that there is like maybe a pretty similar range of temperature values, but maybe we don't have as extreme values. So we might be able to say overlay a box plot on top of this. This is one of my favorite ways to show this kind of data, or just a good way to show data in general. So we get this summary of the data as well as the individual. So then, yeah, and this has been popularized in rain cloud plots. And so rain cloud plots are this way of showing like a density over a box plot over some scatter plot points there. So this is like an extension of that idea. The point of this is to say that we're looking at how the temperature values are different for when solar radiation is present versus missing. So what I did was I wrote a script, which is a little bit complicated here. And I guess that's like part of the talk, is to say that there's like things that are complex here. So we have here, I've got some things where I'm skipping out, like I'm removing some missing values from the temperature data, and then I'm also doing some calculations for the mean difference, and then I'm getting the standard error and the standard deviation. And if you look at this and you think, okay, so we're like doing some standardization, and then we're dividing by things and subtracting means, and so it's like, what is this? This is actually a t-test. For whatever reason, in year one of my PhD, I was handwriting a t-test to do this calculation. I wanted to say, like, if I look at these values, I want to see, like, if I were to subset these into solar radiation missing and present for the temperature data, I want to know if the mean values of temperature are different depending on if solar radiation is present or missing. And so that is what this code here is doing. And so after a bit of iteration, I had a bit of an improved script. So I was really happy with this because I had my two variables at the top here. I had air quality for solar radiation and air quality for temperature values. And I called this, say, var missing and var interest. So when this one is missing, I'm interested in this one and how those values are different. And then I break it up into, so which is.na says which of these values is missing, and which of these values is complete. And then I would subset those. So I would have of my variable of interest, which is the temperature value here. I'm effectively subsetting this data. So I'm splitting up temperature into two pieces according to when solar radiation is missing or not. And then I'm doing a t-test on those values here. And that's what we get. And so that's an improvement. And I was happy with that. Because I was like, oh, great. All I need to do is I have the script and I just change the thing at the top and I just swap out the variables and that's great. Um, and and then I did the same t-test again. And so then as I was going through this, this was like a different example with some different data, and you start to sort of copy and paste the same script in different locations. And so let's play a game of spot the difference. Like, how are these, what's the thing that's different here? A classic issue with this kind of thing is, have I made a mistake? And like, do I just copy it all again? So let's just take a moment to find the things that are different. So the things that are different are these variables here. This has changed. And then I guess the problem with this is that at the moment, I'm now like, are the other bits the same? Have I made a mistake? Have I called something else? And I actually haven't. There's nothing different except for these two values. But now I've kind of spent some time, I kind of wasted some time because I've focused in on this, but then I've also spent energy like really double checking and kind of manually doing this diff. And I think that's like, it's a problem. Yes, Ben Harrop has said that ozone solar, correct. Those things are different, but yeah, but now I've spent time trying to check that the rest of the code has changed, and I don't know, and it hasn't. And I guess I want to have a brief aside about how I write from like how I came to this and what I was asking people about, like when I came to this script, and I was like, I want to like this feels wrong, like this approach of copying and pasting this, it felt like there was a better way. And I asked something like, is there a way for me to change the variable at the top of a script so I can change what variables I run in a whole script? And I was kind of met with I had a really good like group of people around me who were helping teach me R in my group, but I feel like I just was early enough in my career that I didn't really have a good way and like the right mental model to describe the problem I had. And I kind of wish I'd talked a bit more about like a need, like I need to repeat the same task many times to compare different variables, and is there a better way? So yeah, it was like I guess that was like that was tricky. And I wish I had started with this need. So eventually I wrote a function for my missing data problem. I called it missingness impact, and it takes arguments when missing is different. And it was just a little bit more concise, and I felt pretty good about that. I eventually learned how to do this. But I feel like I'm kind of skipping over some details here. As I've kind of jumped out to the solution, hey, I wrote, a nice function. Here's something I prepared earlier. But I want to talk about how to think about writing a function. And this is kind of like a take on how to draw the owl, how to draw the tick. You carefully draw an oval in the center of your paper, and then you bisect the oval by drawing a line through both of its poles, and then you draw the tick holding an oval with the line through it. So this is, just a different play on the how to draw an owl meme that we've seen before, but I just wanted to show another one. So the tick is a funny show. So functions fundamentally are about expression. It's one of the things that is good about, or the thing that was useful, is that I have my function and it's missing this impact, and this thing when missing here is the thing that's going to change between these two sets of uses here. So here I'm interested in seeing how does temperature change when solar radiation is missing, and how does temperature change when ozone is missing? It allows me to really focus in on the thing that I actually care about and to express that idea and that complexity. Um, and as I'll say at the start of this talk, like writing code is writing. Like writing takes iteration. Good writing is about good expression. And like what makes good code is code that I think is well expressed. You're expressing the complexity. It's easier to understand. And I want to talk about like how do we teach people to write functions? Because this is just, I think, something that is I find hard. Um, One thing that often comes up when you teach functions is this idea of don't repeat yourself, dry. And the sort of the saying goes, if you copy and paste the same code 3 times, you should write a function. So if I'm copying my code, a couple of times, then I can think about writing a function. And I guess part of the issue I have with don't repeat yourself is that I think it's a good rule, but it doesn't necessarily capture, I think, as much of like I think there's another way to say this. Like if I've only copied and pasted it twice, should I still write a function? And so instead, I want to talk about dry with 2 R's and then credit to Miles McBain. Don't reread yourself. So if you reread your code 3 times, then you should write a function. It's less on the fact that you're copying and pasting code, and I think it's more actually targeting the real problem. It's not just about copying and pasting, it's about a problem of expression. So how do we think about designing and writing a function? I really believe that functions are tools for expressing complexity. This is also sometimes called abstraction or abstracting away. You might hear people say something like, I am abstracting away this problem, or I'm abstracting away this like challenge, or what's the pain that we want to abstract away? And also thinking about like what is the complexity that we want to express. And I think that there are 2 approaches. You can go outside in and you can go inside out, are the ways that I think you can think about this. So going outside in, I recommend you start with some pseudo fake code where you sort of imagine you've already wrote the function and you ask yourself like the name, like what am I trying to do? What evokes the action? The inputs, like what piece of information do I need to provide? Like what does this action need? And output, like what do we give back? What do we return? And once you're happy with how it looks and how you thinks it will work, so you're sort of writing out this fake code, I find it's generally easier to write the rest of the code. And this approach is actually something I really embraced thanks to Ira Wang and Michohara Wild when I was at Monash. They're 2 very talented art programmers and also just really kind people. So I really appreciate the time that they took with me to talk about this because it really, I think, helped shape the way that I think about how to write good R code. Now let's go back to what we're trying to do. We're looking at values of, say, temperature or some given values, and we want to see how those values change according to the missingness of another variable. And we've got this script that kind of does that in a relatively, there's only 6 lines here, but there's a bit of complexity there. So we're thinking about this is the code, this is the problem. So going outside in a sort of template, you have some output and then a function. What am I trying to do with some piece of information and another piece of information? So what am I trying to do? I'm trying to name something that evokes the action. So I'm thinking like, is X statistically different when Y is missing? Like, what's the impact of Y on values of X? Or like of the missingness of Y on the values of X? The inputs, what piece of information do I need to provide? I need a variable whose missingness we're interested in, and I need a variable whose values are impacted by the missingness. And the output, we're returning a t-test result. So going outside in, again, it's a process of iteration. I'm just writing out some pseudocode here. I'm going to say impact of missingness. Like, does this evoke the action? I'll say variable is missing air quality solar.r and variable impacted. So that's sort of starting to communicate the thing that I want to do. And then maybe I might go, oh, is it like missing difference? Maybe missing this impact. That like feels good. Okay. And then I've still got these other 2 arguments, and I might go through variable going missing and variable different. Like maybe I'll go variable missing instead of variable going missing. I don't know if I really need the going. And then is different. That might, instead of saying variable, it's like a bit more concise. Um, But then if it's like when missing, that's a bit more succinct and is different. That feels pretty good. I feel like I'm kind of arriving at, the shape and like what we call the function signature. So that feels good. And I find that starting up this initial process of like, how do I shape this? What's the name? What's the inputs? What's the output? I find that really helpful. So outside in focuses on how the user interacts with your function. And this is just one hard part of the things. You still need to zoom in to the code details. You haven't actually written anything yet. And this outside will impact the inside. How you think about what the user wants and how you interact with it will also dictate how you write the code. But also the in like it's both. Like the inside will also impact the outside. Like you can't always do the tricks that you want to do. It's you need to express that same intention inside as well. And there's this really nice quote that I really like about science and engineering. And I think that we are like kind of balancing this idea of exploring and understanding the problem space when we're writing code. And we do go back and forth between writing out the function overall, and then we go into the code and we step back out. And we're sort of moving between this sort of like zoomed out level and this zoomed in level. And the quote is, in science, if you know what you're doing, you should not be doing it. And in engineering, if you do not know what you're doing, you should not be doing it. Of course, you seldom, if ever, see either pure state. And I really think that this is like what we're doing. Like we are, you don't always know what you're doing, and then you have to kind of play with the function and work with it, and then you kind of know what you're doing, and then you go back, and it's sort of this cycle. And this cycle, I've heard called going up and down the ladder of abstraction, which is this really awesome essay that's written by Victor, Brett Victor. Um, I'll show you this website in a moment. It's just beautiful. He says, how do we explore? If you move to a new city, you might learn the territory by walking around, or you might peruse a map. But far more effective than either is both together, a street level experience with high level guidance. Likewise, the most powerful way to gain insight into a system is moving between levels of abstraction. So he's got this lovely website. It's called Up and Down the Ladder of Abstraction, and it's around how do you teach this car with an algorithm to stay on the right side of the road? And he says at each step you can move forward 1 pixel, and then there's like a video, and he says, let's say if you're left or right, you turn by 2 degrees. And then he goes through and says, well, if we control time, like we don't have to watch it each time. If we want to change this, then like what if we had a little slider and then we can suddenly see what that looks like in our own time? And that's pretty cool. But then we might want to control it. Like you might say, okay, I want you to turn by like 1 degree or 3 degrees, and then we can sort of see what that looks like. And it's a little bit better, like maybe. But then he talks about what if you abstract over time, and suddenly it's like, oh, that's cool. So now like we can see and play with these different levels of abstraction here. That's cool. So now I actually get a plot of this, and it goes on and on. And I just think it's a beautiful, it's a really beautiful, it's just a lovely essay. And I guess onto this note of maps, I just thought I'd share something from my personal experience. Which is say if you're looking at a map, so this is a map of San Jacinto in California, um, and San Jacinto Peak is here. This is the top, and so like a topographical map will tell you, you can say that these lines here they're closer together. This is steeper, and these lines here are a little bit easier. So like maybe this will also guide me. There's like some tracks here, so I can use this to help plan my approach and how I think I might get up this mountain and what I'm going to do. But there's also the difference of a street level view, which is me on top of this mountain, it was covered in snow, which was very, very unusual at the time of year. And so you get these really different perspectives. You're not just so like looking top down is very useful, like to think about how you would approach something, but also being there on the ground at the street level is different. You can't always get the whole experience just by looking at a map. So you need both. And so I think that one way to write functions is going outside in and then inside out. I think you can also go the other way. You can, like, sometimes you have code and you're working with it, and then you kind of clean it up and then you move outside and back in. I just think that this can be useful to go outside in first. So now we know what we want the function signature to be, and let's go inside. So we have our code. We've got is different, is air quality, temperature. When missing index, we've got which is .na, which is not NA, and then eventually we're doing a t-test. So I'd say like if you're starting here on the inside, start with the bone. So we've got our signature now. We say missing this impact gets function when missing is different. And then we'll just paste that the body of the code in there. Now we're going to have to tidy up some things because is different is no longer needed. So we've just plopped that in so we can get rid of that. And when missing is also this code here. So we're going to need to update those parts. And so we might start like commenting some things out. And then we might remove those bits because we've just got when missing instead here. We don't need to write in the actual variable names. And so we've got those now. That's what we've just changed in this step here. And then we return this last thing, but we need to return like in a function, the last thing you do is the thing that's returned. And so typically when you assign in this step here, you are very likely to not get this thing. It will just assign it and then it'll clean up at the end and you won't get it out. So you need to have the last thing is the thing that is returned. And then cleaning up old lettuce. This is a phrase I got again from Holes McBain, which is removing those unused comments. This is sort of like that hopeful lettuce you have in the fridge, where you've got a plan for a salad or something, and then eventually after a couple of days, it's just a bit old and wilted and a bit sad, and it's just time to throw it out, you know. And so I often have these comments in my code where, you know, like you've worked hard on it and and so just laughing at Emily like, wow, calling me out. I know it was like it's I do it too. And I think you know, it's like it's there like because you're not quite ready like to get rid of the code. I find like when I'm writing a talk, I usually include like a morgue or like a cutting room floor section at the end of my talk where I've written like a slide that I really like and I'm just not ready to delete it yet. So I just put it at the end of the talk or the end of a Word document. Like if I'm working on something like a Cordo document, I put this morgue at the end. Um, and um, and yeah, anyway, so just we cleaned that up. Great. Good. Okay. So now we've got like things are a little bit tighter here. And I guess the thing I want to say is this is a process of iteration, and I sort of want to map out some of the different ways to do it. You can start by having a think on the outside and the overall larger scope, and then you get to the inside of like, right, but how do I do the function? Just like plop the code in. We're going to do some neat little tidying out. We can comment some things out. We'll get rid of them. And the before and after of, you know, like 7 lines of our code and an 8-line function here. Um, Part of this as well then, like you've designed it, you've got to use it. You've got to see, okay, like how does this feel when I use it? Like maybe it might change some of the output. You need to remember you've got to assign the output of the function to something as well, so we can use it later and use it in an example or something like this. But yeah, so the outside in approach, you name the function. What am I trying to do? Something that evokes the action. You have your inputs. What piece of information do I need to provide? And the outputs, what are we returning? And inside out, you copy the text into the body, you identify the complexity that you want to manage, and you abstract the complexity. These parts, I think, are all hard, and I'm going to talk a little bit more about them. The problem with dry and circling back to this idea of like don't repeat yourself, I think that the problem that we're dealing with is complex code. And the don't repeat yourself, it treats the symptom of repetition, but the cause is actually expression and reasoning. That's the reason that we're repeating ourselves. And so I think if you just say, don't repeat yourself, write a function if you copy and paste 3 times, That's you're only repeating yourself because you haven't expressed yourself well. Um, and a function isn't only needed when you repeat code, is one of the other things I want to get across here. So I see this sometimes where people are like, I wrote a function, here you go. And then like you just take the script that you went in, you just wrap a function around the start and the end. And it's like that's not a good idea because you're not like actually making this complex code easier to reason with by just wrapping it of like in a function. The other way to see this is you might have a script and then someone puts in a function and the function controls like the 40 different ways that you could do this script. And that's also a problem is now you have a function that's very complex and hard to reason with. Um, and so I just really believe that writing a function is about expression. How you explain and express ideas, how you manage complexity, and that while the don't repeat yourself has benefits, absolutely. I think expression and complexity are more powerful ideas. But it does have these really good things like avoiding a copy paste error. This is an important thing, and you only make changes in one place. That's also awesome. So I'm not saying that the don't repeat yourself is wrong. I just feel like there's a deeper underlying problem that is perhaps a bit more useful. And fundamentally, this comes down to the fact that code is for people. I've got a lot of quotes today, and I always like to read them out because I find in a talk I want you to concentrate on what I'm saying and not this at the same time. So I'm going to read it out. We want to establish the idea that a computer language is not just a way of getting a computer to perform operations, but rather that it is a novel formal medium for expressing ideas about methodology. Thus, programs must be written for people to read and only incidentally for machines to execute. I just think that this is such a powerful thing. Um, and I think Hadley Wickham said this. I borrowed this from someone. You are always collaborating with your future self, so you should make this easier for you in the future because you in 6 months is sometimes like a different person and it's very useful and great when you can look back on your code and you've made it easier for yourself. Now, naming things is hard. There's another quote. There are only two hard things in computer science, cation validation and naming things by Phil Carlton. So let's talk a bit about this. What does this function do? Has anyone got any thoughts? My fun gets x times 9 over 5 plus 32. Anything in the chat?
It's temperature, right?
It's temperature. Okay, great.
Yeah.
So
I don't know which way.
yeah, all right. So converting temperature. So we're gonna say, okay, so this is something about converting. So like it's a temperature conversion. Okay. Maybe it could be input to output. That's like a bit more useful. So this is Celsius to Fahrenheit. Okay, good. That tells us which way it's going. The function has now explained that. And then also naming the arguments and the intermediate variables. So now we're changing x to Celsius to make it really clear. It's not just something, it's x. We know that it's like Celsius. And then we're saying, okay, we assign this to Fahrenheit and then Celsius times this plus that will return us Fahrenheit. And so I think that you have opportunities. It's not like with on the outside of the code and the inside of the code to help express these ideas a bit clearer. Um, like the Ben's comment, I saw 9.5 and was thinking about Dolly Parton. I do love Dolly Parton. And this idea of iteration that I'm talking about, where like you're slowly getting things better and working. I borrowed this from the Stat 545 functions chapter. And they talk about this idea of a minimum viable product isn't like you start with a wheel and then two wheels and then like the body of a car and then you eventually assemble it and you have a car. It's that you start with like a skateboard and a scooter and a bike and a motorbike and a car. So you start with things that work. And so I guess like I just want to like emphasize that part of it. Writing your code, using it, not necessarily like belaboring on all of these like smaller details to get it perfect before you start using it is just, I think, a really good idea. And I think what makes functions hard is it's not like the inputs and outputs. It's like taking code, like the code that you have, say, in a data analysis, and finding the parts that need to change. I always found this really overwhelming. I was like, I should write functions, but there's all these things that change, and it just feels like I'm spinning all these plates in my head, and it's just really hard to reason with because then I have to imagine like the perfect function that takes in all these different parts. Um, and Joe Chang had this really good data science hangout. He said there's a level of I got it to work, and there's a level of it works, and I can reason about it. I'm about to read out a bunch of great quotes from Joe just because it's a really good thing. He says, how do you take all this complexity and break it down into smaller pieces, each of which you can reason about, each of which you can hold in your head, each of which you can look at and be like, yeah, I can fully ingest this entire function definition. I can read it line by line and prove to myself this is definitely correct. So software engineering is a lot about this. How do you break up inherently complicated things that we're trying to do into small pieces that are individually easy to reason about? That's half the battle. The other half of the battle is how do we combine them in ways that can be reliable and also easy to reason about? So how do you take all this complexity and break it down to smaller pieces, each of which you can reason about, each of which you can hold in your head? Our working memory is like 7 ± 2, so like 5 to 9 chunks. This is from a paper from the 50s, the magical number 7 ± 2. This is like our limit to our kind of processing information, our working memory. So the point of this is to say like, how do we have this complexity? Like we can't put 50 things into our head, like we can put a smaller number of things. Um, and our memory isn't actually limited by the bits, like, but it's actually by chunks. So it's not 1 8 0 0 1 3 1 0 8 6. Chunks, this is like an actual term in psychology. We can break things into chunks, 1 800 131 086. So practice breaking your code into chunks. I've got 50 lines of a data analysis here. It's not 50 ideas. You can chunk those things into ideas. We have a section for data read-in. We have a bit that fixes column names. We have a bit that tidies up the data. And we can reason with them. And we can find the complexity that they're getting out there. And we can abstract it away. We can start to make it simpler to deal with. And so I want to share with you this, thank you. So this is some data from the Australian Bureau of Statistics. This is the little repo I have called AusEd. And I just thought I'd start by showing you what this data looks like. I'm a big fan of the Australian Bureau of Stats. I think they have amazing integrity. I don't love how they arrange spreadsheets. I think that's not super controversial. This is a useful way to show information for people, but it has a lot of difficulties with, like, there are a lot of challenges with this in terms of how we read this into machine readable format. So this is the people enrolled in study and work for each state and territory in Australia by age groups, and then there's also breakdowns of remote areas and by sex. And then that's people enrolled in study and the population, and then they have some things on proportion and so on. So there's like a bit of detail here. And we have the same thing repeated on each of these tabs. So chunking this up a little bit, we have the variable names, we have the number of people studying in each state or territory, and then we have the number of people, like the population there. And then we also have this year information. And so looking at this here, I might start by breaking this up into a script. And so I might start on the, in this like example, I might have started writing out the code. And so I'll have something that reads in Excel, it skips the like appropriate number of rows. It says like how many rows we should read to as well. Let me clean up the silly names from Excel. And then we're subsetting them. So now we've got, some names like this state territory. All right, we've got like our column names, and there's like a bit of a process to set these names here in the data. That's looking pretty good. And then I'm tidying this up into the educated like section of data. Now I've got some educated data, I've got state, territory, age groups, and then I have people studying. And then I might repeat a similar process for population. And the point I want to make here is that there's this iteration that's going to happen where we're going. So you can have a look at the individual steps I've taken here, but if we just go from 0, 0 to 0, 1, we might instead of wrap this up into a function, and then I might like put this into an R file called read raw education data. And as part of this idea of like going up and down the ladder of abstraction, I wanted to talk about how we can do that because I find that um, I put like typically one function in one file, which is something again I borrowed from Miles McBain. I just think he's got some really good ideas and he's a great guy. So what we can do here is I've got one R file per function, which is a lot, but there's also some really good tools in RStudio and also in Posit. I can say take this function and I can press Command and click, and I can go to definition. I can see this function. So that allows me to sort of go in and out and up and down this ladder of abstraction, which is really useful. So what I'm doing here is I'm defining this function. Like I've defined it, I've sourced it. This now does all the same things. It just reads that Excel data. So now I don't have to think about that. And this one prepares education. If I look at this, okay, this is actually, it's like got a few more things here. It's extracting education column names, extracting row set names, pivot longer educated. Okay, so if I look at this, right, this is just doing this step where I tidy up the names and then extract row set names. It is taking that, slicing it up like by some row numbers, and it's setting the names. Cool, and I can set that row number there. So at each of these points here, I'm trying to do what Joe's talking about. I'm like convincing myself that I understand these individual steps and how they work. And this is the pivoting part. Okay, great. And what's good about this is that now that I have this function written, I get like a pretty quickly a sense of, okay, so we're reading in data, we're preparing it, we're preparing education and population, and then we're combining them. And then I'm going to do a plot. So let's have a read through this. Oh, it looks like I've actually got an error. So that's interesting. Okay, so why did I get an error there? So if I just run this again, okay, could not find extract education call names. So if I look at this, okay, it looks like I've probably forgotten to source that file. So maybe I just need to like go through there. And I've done this on purpose to try and to illustrate, like maybe I just need to source all of the R files. So maybe that's something like, oh boy, write this first time correctly. We're going to do lapply on list of files of things that are in the R directory that end with R. Full names equals true. So that part there should, cool, that looks about right, I think. And then I'm going to do that. I'm going to source. Like, fingers crossed this works. Okay, cool. So now I've sourced all my R files. So really, maybe that's what I should have done in the first place instead of sourcing them individually. So now this should work. Great. Okay, cool. And so I guess the thing I want to show at each of these levels of iteration, we've now got, say, the proportion studying in each age group for each of the states and territories. Cool. But now if I look at this and I say it's 01, 02, so now we might just have one function that's called read educated population. And then that does the thing where it reads it in, it prepares it, it combines the data. Because really, we don't really need all this other detail. We actually just want to read in the data for a given year. So we're actually going to go to like a given spreadsheet and we're going to say at that sheet year, if we remember looking at this, we've got our sheets here. We're just going to read in a given year. And then even more than that, for script 3, what I'm actually going to do is I want to list all the files and then I'm going to go from 2014 to 2023 and I'm actually going to read all of the data in. And then I have all of this data for each year. And now we're getting a lot closer to the thing that we actually want to do, which is just look at how education has changed over time. in each of these different areas. Um, and I guess that's like the point of this like function and the things I'm trying to show you here is that we can step in and we can start this process, like starting out writing some code, taking the complexity, like making it easier to manage. And as we're doing that, we're sort of like an archaeologist are kind of like brushing away the details. And it's like really actually we can get this data into a format that shows us all the information we want across all of these spreadsheets. And I just think that that's like a really powerful thing. Um, Now let's go back to the talk. Cool. So I want to talk through the things where you can go to the function definition with a command and click, or I believe it's Control F or just F12 in on Windows. I also want to show this other thing, which is Control and dot allows you to search for a file and function, which I just think is a relatively unknown thing. So if I have a big file that has many functions in it, I want to go to that definition or just a file, I can say read educated population. I can go to the function or I can go to the R file. And that's like, that's this thing here. That's just like a really good shortcut to know about. Um, I also want to talk about exploring and debugging functions. I'm aware that I'm like getting a little bit close to time here. And I just really think that when you teach functions, you should be teaching them with debugging. Otherwise, you're kind of like building a box that you can't look inside and fix, or you're giving people power tools without safety equipment, or writing software that writes uneditable PDFs, or like a one-way elevator in a skyscraper. We need to teach what happens when things go wrong. And you should be learning debugging when learning functions, because an error when you're writing can feel like punishment. And hanging out with these errors is just like a normal state. It's like that is the general state of programming is actually dealing with these issues. Um, and I want to talk a bit about using the browser very briefly here. So I'm just gonna pop a browser in here, and then I'm gonna show let's just go to script 2. I think this will work. Great. I'm actually just going to borrow this line of code that I wrote here to make sure I source all the files. Okay, and so I've gone into read educated population. I'll put a browser there, and I'm going to run this code now. So now it puts me here, and it like puts me in this browser state. So we see we have a special like browse one. And so the thing that I want to get at here is when so before I used to do this, if I was trying to work out what was going wrong in a function, and I might have resisted like writing functions within functions because I found it hard to replicate the exact same situation, what we sometimes say like replicating state. I would like copy and paste all the code very carefully into like untitled number 12 or something on my studio pane, and I would set everything up, and then I would like copy and paste all the bits out of the function, or I would like create all the objects and then I would step into the function. And this just allows you to do that straight away. So now we see in our environment we have year, and even if you want like a little bit of help in browse, this is kind of wild. If you say help in here, it actually gives you some little details about how to use the browser. So you can type N to go next for next line, S for step into, and F for finish, Q for quit are the things that are important. So I'm going to type N and enter, and we see here that our environment updates with the stuff that's happening inside here. Instead of N and so on, we do also have these buttons here for next, as well as step into, which is really good. And I want to show that briefly now. If I type S and enter here, now I've stepped in to prepare education, and I can go, oh, okay, cool. So how does this work? So I'm going to say N, new names, extract education call names. What's that again? Step into that. Okay, great. And what's raw data? Oh, okay, right, that's that. Okay, cool. So then if I go next, what's new data names, raw? Okay, cool. And then, okay, and then I want to change that first one from X to there. Okay, cool. So now I'm getting a sense like I can interact and I can play with this code. And I just think that this is really important. So I'm going to say F now. I'm going to finish that function. And I'm going to go to the end here and I'm going to say F. And then I can do Q, which will quit and exit out early. So I just wanted to demonstrate that process of placing a browser in, typing help, stepping into and around the functions, allowing you to to debug problems as they arise as you write functions. It's a really useful thing to know about. And I think that this is really the idea of like you're sliding between that user analyst and the developer space in R, which is something that is from Roger Peng's talk. And like also the Hadley's talked about this idea of the practitioner to the programmer. I think this is a thing that we do in R, and it's actually part of the design into it. So another quote for you: the ambiguity of the S language is real and goes to a key objective. We wanted users to be able to begin in an interactive environment where they did not consciously think of themselves as programming. Then, as their needs became clearer and their sophistication increased, they should be able to slide gradually into programming when the language and system aspects would become more important. It's from John Chambers from Stages in the Evolution of S, heard via Roger's talk. And so, yeah, as we cleaned up this data analysis, we focused on things we cared about year, as well as like all of the other like details we abstracted away. So the key ideas of this talk: writing good functions, and teaching functions are my challenges to you. So when we write functions, I think you can start outside in, name, inputs, output, then inside out. And moving between outside and inside is really key to understanding. And we must go up and down this ladder of abstraction from the street level, from the map level. And it's moving between the two states that is really powerful. And you should also really know how to debug. If everyone knew how to use like browser and debug, I think it would just it would make your life easier. So good functions manage complexity, they explain and express ideas, and they can be individually reasoned with, and they take iteration. Um, and for teaching functions, I think that we should emphasize using functions to express ideas and avoiding repetition as a symptom of needing a function. I still think it is useful to talk about it. But yeah, I just think that there's a bigger idea about expression that I think is really good. I think that you should demonstrate the process of writing a function with demos and with writing and moving from outside in to inside out. And I'd also say try and use practical functions, not toy ones. It's why I want to start with kind of a gnarly missing data problem at the start. Your functions should be things that are rooted in making something easier. So if you are going to be talking about Celsius to Fahrenheit, that should be an actual problem that you're encountering and not just like an example, even though I gave it just as an example in this talk. But I think you know what I mean. And we really, again, should be teaching debugging alongside functions. My challenge to you is to start sprinkling functions into your daily use and to use browser or other debugging tools and to read other people's code. Like peer review is a great way to learn, see how they write things. And I want you to question me, like, does this make sense? Thanks to all of these people here. I drew a lot of inspiration from you in lots of different conversations and also like watching your talk. So thanks to Miles, Nick, Cyrus, August, Chitra, Hadley, Jenny, Joe, and Roger. And I've got some references and I'll just stop here on the learning more slide here. There's the talk link if you'd like it, and that's how to get in contact. So thank you so much.
Thank
Thanks,
you so
Libby.
yes, thank you
Great.
so much. That was it was really great to see you walk through that in such a careful way and in such a thoughtful way. It was really, really interesting. I know a bunch of people have to hop as we get close to the hour here, but we do have time for a few questions if people have them. I think I saw just a Somebody asked a question about whether you like the specific like keyboard shortcut I think that you talked about was like
Mm,
whether it worked if you were in a our studio project versus not. And then I'm wondering that actually made me think several of us thought like yeah probably I'm not totally sure. But how do you
mm,
think about when you teach functions, how that intersects with teaching about project management, like how to think about your
mm.
workspace and whatnot. Like as you work with people or teach or like do you find one is important before the other or they go alongside or like how do you think about
Yeah.
functions and like working directories and like how those things intersect?
Yeah. So I always teach people about working directories very early on. I've got a little book called Cauto for Scientists, and I've got a section on our studio here. Um, One of the big things I make sure I like teach is this stuff here. So like make sure you have your workspace set up so you're not setting your R data file. I think that getting these things right at the start is a really good way to remove some pain. And I also have a section on workflow where I will talk about using RStudio projects and the here package. I'm conscious of how this might change as things go on with I'll just put a link to that in the chat. But I'm conscious of that, like how that might change as we start using positron. I think like overall, the sense of having a project and using some way to manage your file paths so that they're transportable between places is more important than how to write a function because I think that that helps set you up in the right kind of space and framework. And I think the idea of having separate projects for different things you're working on is really important. I think to answer your question there,
Yeah, yeah.
yeah.
Yeah, that's great. Ben has a question. Their question is about how you track dependencies across functions. Like if
Hmm.
you have function, it gets used in other functions. How do you understand changes that kind of propagate outward? If you
Hmm.
have functions that use other functions and whatnot, like are you still managing that kind of on a project level, or do you start talking about packages? Like how do you end up talking about that or thinking about that?
Yeah, so I think for yeah, like packages versus projects, I think is come like that comes down to if I am reusing the same code in a different place, then I think that's a time to write a package. I think that as you get functions that do more things, and as they get more complicated, you're calling more functions. So say like that case where I have, this function reads in the data, and then like this next one, it tidies up all this stuff, and then that tidying step has like two other functions in it. Like, because one is about tidying up the column names, and one is about adding something in, or so on. Um, it is tricky to get it like I guess my thought is the function, the way that I'm writing it, like gives me more of a guarantee to understand how this code is written. I'm not sure if it would necessarily be easier to reason with and to test if it was all written unnested out into one script. Um, and I think that it does like become a tricky thing, as you've said there. Like if you've written one function that gets used in several other functions and you need to change it and see what the impact has, like what the impact of that is. I think that that's a pretty natural point to want to write a test to establish some sort of known standard of behavior. Um, and as much as I would like to say that there's like a better or a different way, like maybe there's a script that you could run instead that just checks a bunch of stuff, but that is pretty close like to writing a unit test. So I think when you start to have those dependencies where one function can impact multiple different things, um, that is a place to write a test. I also think there's a principle called orthogonality in relation to programming, which is about like you want to write your code so that you can work on individual features that don't impact each other. Orthogonal being like they're independent. It's not always possible. It's very natural, like for your code to have like functions that are used in multiple different places. But I guess trying to limit that so that your functions are only doing one very specific thing and not many things will help, I think, with some of that dependency problem. So if you had a function that was really low level that uh, did a statistical test and a plot at the same time and returned both of them, that might then like propagate in unexpected ways, and perhaps it could be limited by designing your function to be a lot more narrow in scope. But
Yeah.
yeah, it is a bit of a tricky question, but it's a great question from Ben.
Yeah,
Yeah.
yeah. Yeah, oh, maybe we'll ask one more question. I know we're past the hour, so I want to be mindful of your time as well.
Mhm.
So M. Kerr, who I'm not totally sure the real name there, asked like, just as we come away, like asked a question about like how to study functions to learn about it. Give some examples of things you talked about. In general, how do you feel like you learned how to write good functions? Was it by looking at other
Mm,
people's functions? Was it by reading books about it? Was it just by experimentation? Like how can we like what's a good place to find ways to help us
mm.
kind of understand how functions are can be written well?
Yeah, I think that Hadley Wickham's talk managing many models was really good. Jenny Bryan's talk on code smells and feels was really good. So I think that those are great ways to get some good ideas that are really well communicated. And I think also peer review is great, like having experience with in a friendly environment, having someone talk through some code. Um, and explain it. And for you to do that, like for your own code, is very useful. I often find myself browsing through the tidyverse and tidy models packages to sort of see how they've approached a certain problem. That's also a tricky thing that is a bit advanced. I think like Tidy Tuesdays would be a great place to look to see how other people are doing things. Um, as well as I guess I'd probably say two more places to read. The functions chapter. I've got a few like references in here. So this is if you go to the talk link, which is down the bottom here, that you can get through to all of these. Tidy design principles is just gonna is this book by the Tidyverse team. So design.tidyverse. This talks a lot about very specific things with functions that I think is very useful. And also the functions chapter of R for Data Science is also really nice. Um, and yeah, and I guess I would also encourage you to put your work up online, blog about it, like put it up on GitHub. And I find that doing that is kind of like working in a kitchen, in that if you're working in a kitchen where everyone can see in, and they can see you, then by putting it up online, you might be like a little bit more conscious of trying to keep things neat and tidy um, and yeah, but it's a good
Great.
question.
Yeah, yeah, yeah. Awesome. Awesome. Well, thank you all so much for being here, for those great questions. Thank you so much, Nick, for preparing this talk and sharing with us. It really is really exciting to see, to hear your perspective and also after having taught it a couple times, like what is important, like to get that again. So thank you very much for sharing that. Our next meeting is kind of in the middle of November, and that's that talk with someone who is working here locally in Utah, measuring snow, the impact of snow and climate change, and how he uses R for that. So take a look at that and join us there. And thank you all so much for being here today.
Thanks, everyone.
Great. Thank you.
Thank you so much, Nick. And I am sorry for that Zoom bomber at the beginning. You moved on from that very well. I think
That's
that's
all
the
right.
first time. Is that the first time, Andrew,
Yeah,
we've had like a Zoom bombing?
Yeah, thanks for
yeah,
dealing with that so promptly and so well. That was
Oh,
great. I had
yeah.
a yeah, um, had an issue with the Zoom bomber a little while ago, and I didn't have permissions to kick them out. It was
Oh
terrible.
no. Oh no. That's
No,
terrible.
it was no good.
Oh, that's
Yeah,
terrible. That's terrible.
yeah, but it was no, thank you. I think I just it was a bit distracting in the moment, and then
Oh
I
yeah.
just summoned up all of my love for R functions and used
There
that
you
to
go.
fuel the next.
Perfect, perfect.
Yeah.
Andrew, maybe we can watch and see how bad it is
Oh,
on
hey,
the
JD.
recording
yeah,
and see
yeah.
what we might want to do. So since we recorded it and streamed it, it probably just went up. Maybe we'll take a look and see, can we do some surgery on it? Or I'm sorry. I'm sorry for that, Nick.
something.
Yeah.
We'll take a look at the
a
recording
look at
and
it.
see if there's anything that can be done about it.
Yeah, I'm sure there's a way to like there might be a way to just to trim out a section or something, but yeah.
Yeah. Well, we'll take a look. We'll take a look at that in
I
the
didn't
next day
even
or so.
catch what he was
Like I
screaming
couldn't.
about.
I was so like just like, and I was like, get him out. So I was like not even trying to process what it was. So I also don't know what he was yelling about, but
I don't
yeah.
know either. It was something angry and
Yes, it
yeah.
definitely seemed angry.
Yeah.
Oh man. Oh man. I remember being so like in the early days of the pandemic, like people being so stressed about Zoom bombing, and I think people Zoom bombing into like children's classrooms and things like that. But we've actually never had. This is the first time we've had an
Yeah.
experience like that. Thank you for handling it so well, for moving on, for delivering such a great talk. And it really was great. And it was so short. I think
Mhm.
it was really great to be able to hear your perspective on that.
Yeah. Oh, well, thank you again. And yeah, what's off the rest of the year? Like, are you like PositConf is done? Are you on to
Yeah.
anything? Is there like another thing that's
Um,
coming up for you or?
am I traveling again? I don't know if I have any conferences between now and the end of the year. I'm
Mhm.
doing some family travel. Nothing. I don't think anything else international this year,
Mhm.
but doing a little bit of family travel and um, but day job, plugging away, working away.
Yeah. Yeah. Awesome.
Yeah.
Very good.
Yeah.
Well,
Awesome. How are you,
yeah.
Amelia? Or I don't know if you're able to talk or not, but or if you're there, but it's good. It's so
Mhm.
good. Thank you for coming.
Yeah, it's nice to see Amelia.
Yeah, yeah. Yeah, Amelia may not be
Is
there
she?
anymore.
Maybe not.
Okay, no, there, no, Amelia, it's great. Okay, nice,
No,
nice.
thanks. Yeah.
Yeah, thank you.
Cool. All right. Well,
Oh, yeah, yeah, yeah. Sounds great. Thanks for coming, Amelia.
okay.
Um,
Very good.
yeah, great, great. Great. So is there anything else you need from us? We'll take a look at the recording and see if we think it's like either is it too inappropriate to have up? Can we do a little surgery? We'll figure out what to do.
Cool.
Yeah.
Yeah, it sounds good. But yeah, no, I guess yeah, just looking forward to I don't know, like I'm great to have like I'm really happy to have that up online and yeah, it'd be good. And yeah, I will see you online as they
That's
say.
right.
Yeah.
That's right.
Yeah.
See you online. You
All
have a
right.
good rest of your day and which is ahead of you. It's
Yes.
the end of our day.
Yeah.
Oh
Okay, great.
yeah, yeah, maybe we can even do it like inside of YouTube actually without having
Yeah.
to like download the whole thing maybe.
Yeah, I reckon that's a thing.
Yeah,
If
yeah.
we have to, I did record it on the cloud so I can download that copy if we need to.
Okay.
Cool.
Okay.
Great.
So
Awesome.
we have a backup and stuff. But I think it was something political, but
Yeah.
It was like vaguely political, something about I think the word America or country came up or something, and then all that was in my head was like a scatter plot, and so the scatter plot
That's
just
great.
like I just fully immersed myself
Oh.
it struck me as
in that
very
moment.
Alex Jonesy. But
Yeah, yeah,
Yeah.
yeah. Yeah. Yeah.
How are you guys? I
Yeah.
know that it's a bit distressing when that happens as a host. Like, I hope, like, I feel like just to reiterate, like, I feel really good about how it was handled. I feel
Great.
great
Great.
and really, like, I really appreciate how you moved through that. Like, because it just felt like prompt and like acknowledging, like, hey, that happened and let's move on. I'm so sorry. So
Yeah.
that felt really good. So,
Thank you, Nick. Thank you, Nick.
just
I'm
wanted
really
to,
glad we were able to
yeah,
just like chunk,
yeah,
Yeah, yeah. I'm glad that went. I think it went about as well as it could have. So, thank
yeah,
you, Nick, for
yeah,
sharing that. And I'm really
yeah.
glad that it did go as well as it did. I mean, the talk went fantastic, and that our handling of the
Yeah.
a Zoom bomber went about as well as one could hope.
Yes,
Yeah.
indeed. Great. Cool. Well, have a great day
Thank
and
you.
thanks again so much and nice to meet you, Andrew, and I'll see I might join for the next meeting. Great.
All right.
Cool.
Awesome. Awesome. See you around.
Yeah.
Bye.
Bye.